Imagine a technology that is so incredibly good at breaking into computer systems that its creators decided it was just too dangerous to release to the public.
Yeah.
I mean, you build the ultimate skeleton key, right? And then you realize you actually have to lock up the key itself.
Yeah, it creates this really fascinating paradox
Mm.
because, we spent decades worrying about rogue hackers building automated weapons in a basement somewhere.
Right.
But in this case, the builders are, well, they're a legitimate AI lab. And the capability of the tool they've created is forcing the entire cybersecurity industry to completely rethink its basic assumptions.
Welcome to the deep dive. Today we are looking at Claude Mythos Preview. It's an unreleased AI model from Anthropic, and, diving into their 245-page system card, the thing that immediately stood out to me isn't just that this AI writes code.
Right, because we've had that for a while.
Yeah, exactly. We've had code writing chatbots for years. What makes Mythos completely different is that it operates as an autonomous agent.
Hmm.
Like, it doesn't wait for a human to point it at a target. It actively hunts for these zero-day vulnerabilities across major operating systems and web browsers, and then it just writes the exploit to break them.
And for those listening who might not work in cybersecurity every day, a 0 day is basically the holy grail for a hacker.
Yeah.
It's a fundamental flaw in the software that the original developers don't even know exists yet. So, you've had 0 days to prepare for it, 0 days to patch it. It's completely undefended.
The examples in the documentation are genuinely staggering to read. I mean, it highlights that Mythos found a 27-year-old vulnerability in OpenBSD.
Wow.
Yeah, and that caught my attention because OpenBSD isn't just, any operating system. It has this reputation as literally one of the most relentlessly security-hardened systems on the planet.
Oh, absolutely.
It's the architecture network engineers use to run heavy-duty firewalls. And Mythos found a flaw hiding in there since the late 90s that basically allowed a remote attacker to crash any machine running it just by connecting.
I think the timeline is what makes that so significant because,
Yeah.
human security researchers, literally thousands of them, have been auditing OpenBSD line by line for almost 3 decades.
And they just missed it.
They completely missed it.
Yeah.
The system card also details this 16-year-old bug in FFmpeg. That's a background video processing tool used in, almost everything that streams video on the internet.
Right.
And that specific bug had survived 5 million automated security tests.
5 million tests looking for a flaw, and Mythos spots it, which, implies it's not searching the way traditional software searches.
Exactly.
If I look at the benchmark testing on the Firefox JavaScript engine, Anthropic ran their previous best model, I think it was Claude Opus 4.6, just to see if it could autonomously develop an exploit. Opus 4.6 succeeded exactly 0 times.
Yeah.
Mythos succeeded 181 times.
Yeah. It's a completely different paradigm.
Yeah.
And the UK's AI Security Institute, the AISI, they actually got early access to test this autonomous behavior.
Oh, really?
Yeah, they put Mythos into a 32-step simulation of a cyber attack called the Cooling Tower Challenge.
Okay, what is that?
So it's this incredibly complex multi-stage environment where you have to breach an outer network, then escalate privileges, move laterally through the system, and finally compromise a critical industrial control system.
Like a power plant or something.
Exactly. And Mythos was the first model in history to successfully complete the entire scenario from start to finish, acting entirely on its own.
Okay, let's unpack this, because the obvious question is, how? How does a language model suddenly become the world's greatest hacker? Because previous AI models were like a tool that tells you a door is unlocked. But Mythos is like a tool that opens a door, walks in, finds the safe, and then chains together different tools to crack it open.
What's fascinating here is how the researchers describe its process. If you look at the paper by Abel B.S. Gaia, The Anthropic Morphology of Myth, they describe the model not as a human thinker having a eureka moment. They call it a digital bricoleur.
A bricoleur.
Yeah, a tinkerer. Because traditional automated security tools are very linear. They look for known bad patterns.
Like a security guard checking IDs against a list.
Perfect analogy. If your ID isn't on the list, you get in. But Mythos operates by rapidly recombining fragments of code and logic in this high-dimensional mathematical space.
Okay, let's break down high-dimensional space for a second. If I'm visualizing this for the listener, it's like a massive map where the AI plots every single line of code, every function, every variable, all based on its underlying mathematical relationship to everything else.
Right, and it plots billions of them simultaneously. And because it can see the entire map at once, it notices relationships a human would just never see. It takes tiny, seemingly harmless, low-level bugs, like a slight memory delay here, a minor formatting error there, things a human developer would totally ignore as just background noise.
Right, because on their own, they don't do anything.
Exactly. But Mythos chains them together. It realizes that if you trigger harmless bug A while simultaneously delaying harmless function B, you suddenly create a catastrophic hole in the system. It turns minor glitches into a devastating full system exploit.
So if you build a machine that creates weapons out of harmless puzzle pieces, I mean, you obviously can't just put that on a public app store.
No, absolutely not.
And Anthropic's answer was an outright quarantine. They launched this thing called Project Glasswing, so they refused public release and instead formed a restricted coalition of about 40 organizations with 12 launch partners like AWS, Apple, Google, Microsoft, and CrowdStrike.
The name itself is actually quite deliberate. It's named after the glasswing butterfly, the Greta Otto.
Oh.
The metaphor is that the vulnerabilities in our digital infrastructure are hiding in plain sight, just like the transparent wings of the butterfly. And the only way to evade harm is through absolute transparency.
That's incredibly poetic for a cybersecurity initiative. And Anthropic actually committed $100 million in usage credits to these organizations. The stated goal is to give these defensive heavy hitters a 90-day head start. Like, use Mythos to find and patch all this critical software before bad actors can develop a similar AI.
And that 90-day window is the absolute core of the strategy because of this phenomenon known as the zero-day clock.
Right.
Historically, the time between a vulnerability being discovered by a bad actor and it being widely exploited in the wild that was measured in months, companies had time to issue a patch. Today, that clock has collapsed to under 24 hours.
That is terrifying.
Yeah. The sources detail a recent incident involving the Axios JavaScript library. It's a library that gets 100 million downloads a week. A vulnerability was compromised, and the first automated infections hit the internet just 89 seconds after publication.
89 seconds. I mean, you can't even get a security team on a Zoom call in 89 seconds.
You really can.
But I want to pause on Project Glasswing because looking at the public discourse, reading threads on Reddit, and seeing commentary from security veterans like Bruce Schneier, there is a very loud contingent calling this a massive marketing stunt.
Oh, for sure.
Like
Wow.
building hype by calling a model too dangerous to release right before an anticipated IPO.
Okay.
Plus, running a model that complex, especially an agentic model that loops and thinks it requires vast amounts of compute power.
Right.
So some argue Anthropic might simply lack the server capacity for a general public rollout. So they're, spinning a hardware bottleneck as a security feature.
I mean, the compute bottleneck argument carries a lot of weight in the industry, certainly. Running millions of high-dimensional vector calculations iteratively is astronomically expensive.
Yeah.
However, we have to look at the independent findings from organizations inside Project Glasswing. Cloudflare, for example, ran Mythos against 50 of their own massive code repositories. And they found that, regardless of Anthropic's motives, the capability solves one of the most frustrating bottlenecks in cybersecurity, which is the signal-to-noise ratio.
Right, because older security AI would just flag 10,000 lines of code saying, hey, this might be a bug. It just overwhelms the human defenders.
Exactly. They spend all day chasing ghosts. But Mythos doesn't just flag a potential issue. It actually writes the proof of concept code, compiles it, and attacks a sandbox.
Wow.
If it fails, it rewrites the attack and tries again. It only hands the human defender a report. When it has a verified working exploit, it automates the proof.
That is a game changer.
It is. So whether the quarantine is marketing or necessity, the 90-day window is buying real, actionable time for defenders.
But, and this is a big but, it's only buying time for the defenders who were invited to the club. And this is where the geopolitical reality really crashes into the tech world. Anthropic restricted the European Union's access to Mythos entirely.
The fallout from that exclusion has been intense. If you look at the public forums, there are basically two distinct narratives emerging. One side views this as a natural, unavoidable consequence of the EU's incredibly strict tech and security regulations. They're essentially saying the EU legislated itself out of the cutting edge.
And the other side?
The other side sees it as blatant U.S. tech nationalism. They argue the U.S. is treating advanced AI like restricted munitions, deliberately withholding defensive tools and widening the cybersecurity gap between the U.S. and Europe.
Treating math like a weapon. Which leads to this brilliant paper in our stack from media at LSE. They coined the phrase, the myth of containment.
Right.
The premise is so simple, you cannot lock up math. The moment Anthropic published their system card and proved this architecture was physically possible, they fired a starting gun. If the US won't share the lockpick, the rest of the world is just going to build their own.
And they did. It didn't take years, it took weeks. The open source counter movement responded with Open Mythos.
Yeah, this is wild.
An independent developer named Kai Gomez looked at the public research, pieced together Anthropic's clues, and built a PyTorch reconstruction of the entire Mythos architecture in just 12 days.
12 days. 12 days to replicate a supposedly unreplicable superweapon. I watched the breakdown of this from the Prism Labs YouTube channel, and the engineering under the hood is just fascinating. They explain that Open Mythos uses a looped transformer with a mixture of experts.
Let's unpack mixture of experts, or MOE, for a moment, because normally, instead of having one massive generalized neural network try to solve every problem like a general practitioner in medicine, the model contains specialized subnetworks.
Okay.
So you have one expert for memory management, one for cryptographic flaws, one for network protocols. When a problem comes in, a router network instantly delegates the task to the most relevant experts.
So it's incredibly efficient. But the real magic trick Prism Labs points out is something called adaptive computation time.
Yes.
Because older AI models process every prompt at the exact same speed. It's totally rigid. Here's where it gets really interesting. Open Mythos is more like a student taking a test.
That's a great way to look at it.
Right. If you hand that student an easy arithmetic problem, they spend 5 seconds, write the answer, and move on. If you hand them a complex calculus equation, they sit there for 10 minutes. They loop the problem over and over in their head before writing anything down. The model actually reasons silently in latent space.
It learns a halting probability, automatically allocating more compute time and more internal loops to harder security problems before it generates any output.
But looping complex math poses a massive technical hurdle, doesn't it?
It does. When you loop a mathematical operation dozens or hundreds of times inside a neural network, tiny numerical errors, even a fraction of a decimal point, they compound exponentially.
Right.
It's a phenomenon called residual explosion.
Mm.
Without safeguards, a model thinking that deeply should honestly just start outputting total garbage.
I was completely stuck on that point until I saw how Prism Labs explained the solution. They solved it using LTI constraints specifically, and negative diagonal matrix parameterization.
Which sounds incredibly dense.
Oh, absolutely. But the concept is actually quite elegant. The way I translated it in my head was to think of it like gravity in a solar system.
Okay, I like that.
If you just spin planets around a star, any slight bump sends them flying off into deep space. But the negative diagonal matrix acts as a mathematical gravitational pull. It guarantees the system is contractive.
Right.
Meaning every time the math loops, instead of spiraling out of control, the data is pulled slightly tighter toward a stable, fixed point. The error margin shrinks instead of growing.
This raises an important question, though, because with that stability, they can train the model using something called three-stage grokking.
Right, grokking. Memorization, in-distribution generalization, and systematic generalization.
To put that in human terms, the first stage, memorization, is like a student memorizing the multiplication table. They know the answers, but they don't really understand the underlying logic.
Yep.
The second stage, in-distribution generalization, is the student learning to apply those rules to pass a standard math test. They can solve problems they haven't seen before as long as they look similar to the practice test.
But the third stage, systematic generalization, is where it gets scary.
That's where the paradigm shifts entirely. In systematic generalization, the model extracts pure, reusable concepts of logic.
Wow.
It's like the student not just passing the test, but inventing a completely new field of mathematics. The AI learns fundamental computation primitives that it can apply iteratively in completely novel ways to environments it has never even seen before.
And the fact that a single developer could reverse engineer this architecture in less than 2 weeks. It proves the media at LSC paper right. The myth of containment is busted.
Completely.
The defensive window Project Glasswing is trying to buy is closing incredibly fast, which leaves European institutions in a very precarious position. They are locked out of the proprietary U.S. models, but the open source community is handing them the blueprints to build their own.
Right, so the question becomes how they operationalize it. They can't just sit around waiting to be attacked by bad actors using these lead architectures.
And they aren't. They are pouring vast resources into massive defensive initiatives, the most critical being the European Cyber Aid project.
Yeah, cyber aid is huge.
This is designed to enforce the cyber resilience of critical infrastructures, specifically in the financial sector. We are talking about the central banks, the payment processing networks, the trading platforms, the systems that literally hold your money.
It's an incredibly complex environment, though, because they aren't just fighting hankers. They're navigating a really dense maze of European regulations. You have DORA, the Digital Operational Resilience Act. You have NIS2 for network security, and of course, GDPR for data privacy.
Let's focus on DORA for a second because that's the real catalyst here. DORA doesn't just say banks need to be secure. It legally mandates that financial institutions prove they can survive and recover from a catastrophic cyber attack.
There, you had to demonstrate resilience.
But how do you prove you can survive an AI-driven attack without actually letting an AI attack your live banking systems? I mean, that would cause global financial panic.
And that is exactly where the CyberAid Proactive initiative comes in, and where tools like Open Mythos are perfectly suited. Inside CyberAid, they have developed an autonomous attack generator called Xenon.
Xenon.
Yes. It uses these large language models to relentlessly simulate highly sophisticated, multi-step cyber attacks.
But again, they aren't unleashing Xenon onto the live servers. CyberAid uses a service called Dioscuri to create a digital twin.
Right. A digital twin is essentially a high-fidelity virtual replica of the bank's entire digital infrastructure. It's a perfect sandbox.
So it looks just like the real thing to the AI.
Exactly. It mirrors the servers, the firewalls, the employee access terminals. Financial institutions can safely unleash the Xenon attack generator inside this virtual replica. The AI attacks the dummy bank millions of times, finding the microscopic flaws in the armor without ever touching the real-world production systems where the actual money sits.
That makes total sense for the infrastructure, but what about the data? I mean, if you're scanning banking architecture to train these defensive models, you are inherently dealing with incredibly sensitive customer data. GDPR absolutely doesn't let you just upload European citizens' banking details to a central AI server to train it.
No, definitely not. They solve that through PySift, which is an open source framework for federated learning.
Federated learning is one of those concepts that sounds like magic until you break it down. I like to think of it like sharing a recipe.
Oh, I like where this is going.
If 10 different master chefs want to collaborate on the perfect cake, they don't have to mail all their secret ingredients to a central kitchen, right? Instead, you send the recipe to all 10 chefs. They bake it in their own private kitchens using their own private ingredients. They figure out what works, maybe a little less sugar, a little more vanilla, and they only send the improvements back to the central recipe.
The recipe analogy is spot on. In the context of CyberAid, the central AI model is the recipe. It gets sent directly into the private, secure servers of 10 different European banks. Right.
The model trains itself on their highly sensitive proprietary attack data. But the raw data, the customer names, the account balances, the transaction histories, that never leaves the bank's local server.
Wow.
Only the mathematical learnings, the updated weights and biases of the model are sent back to the central hub. So they collaboratively train a master threat detection model while maintaining absolute cryptographic privacy.
So what does this all mean for the listener? If I'm putting all this together, it paints a wild picture. It means your bank isn't waiting for a human hacker in a hoodie to find a vulnerability. And they aren't relying on human security engineers to manually write a patch either.
No, not anymore.
They are using highly capable AI agents to constantly relentlessly attack a perfect simulation of the bank. They are finding and patching the microscopic holes in the digital vault at machine speed, resolving vulnerabilities before a real-world attacker even knows they exist.
That is the overarching theme of every single source we've looked at today. Speed.
The arms race between cyber offense and cyber defense has fundamentally shifted domains. It is no longer operating at human speed. And the gap between a vulnerability existing and a vulnerability being actively exploited is effectively disappearing.
It's an immune system running millions of simulations a second. We've covered incredible ground today. We started with the sheer disruption of Claude Mythos, moving past code writing to become an autonomous digital bricoleur capable of breaking 27-year-old hardened code.
Right.
We explored Anthropic's attempt to quarantine the math with Project Glasswing, aiming to buy defenders a 90-day head start against the collapsing zero-day clock. We saw the geopolitical blowback of excluding the EU and the open source rebellion proving that with tools like Open Mythos, containment is just impossible.
Absolutely impossible.
And finally, we looked at how European institutions are applying these autonomous agents through the CyberAid project, using digital twins and federated learning to build proactive, self-healing defenses for our financial grid.
And that transition to self-healing infrastructure isn't just a nice upgrade, it's a necessity. When the attacks are automated and reasoning in latent space, the defense has to be equally autonomous.
Which leaves us with one final thought for you to ponder. If we are entering a world where AI agents become the primary developers, finding, writing, and patching the code in our critical infrastructure at speeds we can't even comprehend, we're crossing a very strange threshold.
We really are.
We might soon reach a point where our banking systems, our power grids, and our communications networks are running on code that is perfectly secure. It will be mathematically flawless. But because it was written by an AI chaining together high-dimensional logic, it will be entirely incomprehensible to the human engineers who built the systems in the first place. We have to ask ourselves, are we ultimately securing our digital world at the cost of ever understanding it again?